Hello, welcome to our video. As I promised during our lesson today, I'm going to show you kind of special task which I'm pretty sure you would be able to solve because all the information for solving this task you already have. And this task says calculate for which real parameter m the function is increasing if the exponential function is given by the equation y equals m squared minus 6 over m, the whole expression to the power of x. Let me just for a while provide you with the translation of our task. You can read it. Okay. Before I'll start with solving this task, the first thing we have to say is what the parameter m means and what will be and why are we interested in solving such a task. Parameter m means, and as you can see, it could be any real number, and we are looking for the criteria which real numbers will fit into this task so that this exponential function is increasing. And let me just show you what it means, parameter m. So for example, if we would have parameter m equal to number 1, then it would mean that our function would be given by the equation y equals 1 take away 6 over 1 to the power of x. Basically what I did already, instead of m's in my expression I put a number, and now I have chosen 1. I want to show you something, and it really means that there can be any number, and as it is called parameter, depending on the value of the parameter the function will behave like different ways. So in this case it would mean that our function is defined by the equation y equals -5 to the power of x. Okay, and this is something to remember. Our exponential function, and as we already know, exponential function is defined by the equation y equals a to the power of x, where it's necessary that a is greater than 0 and a is not equal to 1. Okay, we have already discussed why and what it means, so I'm not gonna talk about it again. So in this case, if m is equal to 1, then it's not exponential function, so the function is not defined like exponential. Okay, not defined. Now let's have a look what will happen if I'll choose m being 2.5, and you will see later on why I choose these numbers. So then my function will be given by the equation y equals, and 2.5 squared is 6.25, take away 6 over 6 to the power of x. Again, instead of m's in this expression I have put the number 2.5. okay, 2.5, and I made a mistake, I'm sorry. So here must be number 2.5 to the power of x. So it would mean our equation our equation would be y equals, and you can try it by your own, but it's gonna be 1 over 10 to the power of x. And as you can see, in this case, if m is 2.5, our function will be decreasing. We already know this because if a is between 0 and 1, then the graph of the function looks like this, and we already know that this function will be decreasing. The last parameter I want to show you and to talk about is if m would be number 4, then the equation would be 16 take away 6 over 4 to the power of x, which would lead to the equation y equals 5 over 2 to the power of x, and it would mean that the function given by this equation would be increasing, because the exponential function is increasing if parameter a in our general definition or equation is greater than 1. So it would mean a is greater than 1, which is because 5 over 2 is greater than 1, and we already know that the graph of this function, and if a is greater than 1, the function will look like this, and we know that this kind of function is increasing. So as you can see, for m being 4, the function is increasing. Basically, to summarize this, in our task we are interested in finding all the values which we can fill in the equation of our exponential function so that the function is increasing. Let's find out how do we do. Okay, so I am not gonna use this anymore. As I already said, and we already know, the function, any exponential function given this form, is increasing when a, or the base, is greater than 1. What it basically means for our function? It means that the expression or the base in our function, which is m squared minus 6 over m, must be greater than 1. Okay, and as I said, these are all information you already have and all the skills you should have to solve this task, because the main idea is the fact that the function is increasing if a is greater than 1, and then it leads to the quadratic inequality which we were solving before, but I'm going to solve it for you now. Just to remind you, it basically means we solve any equation. The easiest way to solve the inequality is to compare, and especially if it is like fraction, to compare it with 0. How can I compare it with 0? There is a problem because there is no 0 on the right side, but I can very easily get 0 there if I will subtract -1 from both sides, which would lead to the inequality m squared take away 6 over m minus 1 is greater than 0. Okay, next thing we want to, and we have to do to solve this inequality very easily, is to have like fraction there. So we simply find the common denominator, which is in this case very easy, it's m. So our inequality will be m squared take away 6 minus m is greater than 0. Okay, now we know that any fraction is greater than 0 if the numerator is positive, then the denominator must be positive as well. In this case it would be greater than 0, or another possibility is that the numerator is negative number and the denominator is also negative number. In this case it would be again positive number. So having this in mind, we are going to find like 0 points, because we want to find where our quadratic function is positive or negative. and then also the denominator positive or negative. So we need to find 0 points, which means first of all we need to solve the quadratic equation m squared take away m minus 6 is equal to 0. For solving this quadratic equation I will use the factoring method, which basically works like this. We are looking for two numbers. If we add them up, they will give me the result like -1, and if I multiply these two numbers, it must give me the result -6. So what are my numbers? And I'm looking for whole or for integers, so it's good. How can I get that number -6? I can get it when I multiply 1 by 6. Of course, one of them must be negative, but if I add these numbers up, they are not gonna give me -1, so there is only one solution, and the solution is -3 plus 2, which is -1, and -3 times 2, which is -6. So this quadratic equation can be written like m minus 3 times m plus 2 equals 0. From this I can very easily read that my roots m1 are like 3, or m2 is equal to -2, and we already know that this function's graph is parabola, and as our a parameter in front of the quadratic term is positive number, we know that the parabola will open up, and we have our roots, so it will be passing through the points -2, 0 and 3, 0, and the shape is parabola, so it will be something like this. It's not very important to know how and where it intercepts y-axis, because we are looking for the information where the values of the function are positive, which is here, and where the values of the function are negative, which is here, and where the values are positive, it's again here, because this part of parabola is above the x-axis, and this part of parabola is under the x-axis, so it means there are negative values. Okay, now the easiest way is to construct the table, and yeah, I'm missing one more 0 point, so my 0 points are m okay, my 0 points are, let me do it this way, m1, m2, and I have one more 0 point, let's name it like m3, which is equal to 0. Where this 0 comes from? Of course, 0 point comes also from the denominator, and m equals 0 only if m is equal to 0. So these are my 0 points, which will divide the set of all real numbers into 4 intervals. The first interval will be -infinity, 2, and I'm looking for the smallest number. The smallest number is -2. The interval is opened. Why is it so? And the answer is very easy, as I'm solving the inequality where my left side is only greater than 0, and it is not greater or equal to 0. That means I cannot get 0 in the numerator. That's why -2 is excluded, which is good news. I don't have to care anymore about this. My next interval is from -2 to 0. Why is the interval opened here? It's very simple and easy, because this fraction is not defined for m being 0. That's why I have exclude 0. Then my next interval is from 0 to 3, again opened interval, the same reason as for number -2, and the last interval is from 0 to the infinity. We construct this table, and we already know why we do so, because we want to find out where our fraction is positive or negative. So we will be looking for the combination of two plus signs or two minus signs. So let's find out how the expression m squared minus m minus 6 behaves, and this is the reason for drawing the parabola, because now I can very easily say that here the values will be positive because I'm on this part of the graph, or let me do it this way, I'm now on this part of the graph. Then I'm going from -2 to 0, and as well from 0 to 3, which is negative. So I'm now in this part of the graph where all the values are negative numbers, and from 3 to the infinity, again, I'm sorry, I'm gonna use the same color here. Again, all the values are positive because I'm on my parabola on this part. So this is it. How is it with the m? How it behaves? As we already know, this is like linear function, and it is even the parent function. We already know, let me take this color, that the graph of linear function is straight line, and as it is parent function, it passes through the origin, and so it means here my function gets only negative values and here it gets positive values. So it's very simple: negative, negative, positive, positive. Now I'm looking, as you can see here, for the combination of two positives or two negatives, and then this fraction will be really like a positive number. So in our case, only this interval fits, and in this interval. So basically we can make the conclusion that m is from interval -2 to 0, both opened, union 3 to the infinity. Okay, so this is the solution of our inequality. Basically we started here, and this was the condition for the function defined at the very beginning to be increasing. Okay, let me just show you this for a while. Okay, so to summarize and give the result for this exercise, it would mean that if parameter m is from -2 to 0, I will use this tricky thing. If parameter m is from these two intervals, then our function is increasing. Okay, and yeah, I want to show you something, how you can evaluate if your solution is correct. And again, for such a thing, as I advised you already a lot of times, you can use Desmos. There is really a nice feature where you can work with the parameters. So let me give you a couple of screenshots from Desmos. For example, let's see, when and I will do it like from another direction now. When I was showing you at the very beginning, and I was explaining how the parameters work and what are they good for, I took m being 4, and as you can see, this is the print screen from the Desmos. here is our exponential function, and here you can Desmos will do it automatically, and by moving this slider here, the blue dot, to the left or to the right, the value of the m parameter will vary, and you will see that the shape of the graph will change. So for example, here is again the proof that if m is equal to 4, the function is really increasing, and m being 4 is really from the interval where m is okay, and the function is then increasing. Let me show you if m would be 2.5, that the function is really decreasing, and the graph of the function will look like this. This is again gonna be print screen from Desmos. As you can see here, m is set to 2.5, and the graph is having like this shape, and it is really decreasing. Okay, let me show you what will happen if m is equal to 1. Okay, where is 1? Okay, if m is set to 1, then as you can see, there is no graph, so the function is really not defined for m being 1. Okay. Last thing I want to say is that there can be like 4 kind of tasks when talking about the exponential function, and how it behaves depending on the value of the expression with any parameter. There can be like 4 tasks. The first task is find the values for m so that a function is defined. In this case, it would mean that you are solving inequality when a is greater than 0, and be careful, you have to also evaluate and find out for which m a is not equal to 1. Okay, because only if this condition is met, the function is defined, and we can talk about exponential function. The next task could be, you can be asked to find the values of parameter m so that the function is decreasing. It would mean that parameter a must be greater than 0 and less than 1. Okay, so this is the condition. Probably I will make one more video about this task, because here you have to be careful, and in this case you'll be solving like 2 inequalities. The first one will be a is greater than 0, and the second one would be a is less than 1. Okay, by solving these 2 inequalities and making the disjunction, you will find the final solution. The third task is the task we did right now, increasing. And increasing will be if our parameter is greater than 1, which we did. And the fourth task could be when the function is not defined. So it means you are supposed to find all the values of parameter m when the function is not defined, and in this case it means you are looking for this, or a is less or equal to 0. Okay, so this is our condition. Basically, it is easier to find this sometimes and then do the complement, but of course it depends. maybe I'll show you in the next videos also this kind of task. Okay, I think I said everything and it was clear, and I'm looking forward to make new video for you. Enjoy the time. Bye bye.